All right, so in today's lesson, we are looking at using matrices to represent information. So they'll give you a little bit of data and they might ask you to construct. So if you remember the other day, we talked about different types of matrices as well. Remember, if we had a row matrix with just one row, and then you had you could have a column matrix with just one column. So they might be setting that up, asking you to set up things particular way. So let's have a look. So this was like, it probably was a table. Sometimes when it gets put on the iPad, it gets a bit broken up. But we probably had a table of values here. And, there you go. It was residents, TVs, and computers. So it says construct a matrix to display the information. So all you need to do is, obviously, you get the square brackets, and we'll just write the information out like this. So I'm just separating those numbers and they become all the elements. Okay, so what is the order of this one? How many rows was it?
Three.
Good. 3 rows and 3 columns. So we'd write the order of that. Okay. So you can see here in the next bit, it says construct a row matrix to display the numerical info in the table relating to household B. So that would just be this information. So we're going to just construct a row matrix. So we'll just see 6, 2, and 3. Yep, excellent. That's what someone just said. This is a square matrix because it has the same amount of rows and columns. So this one is a row matrix because its order is, what's this one's order? 1 by 3. Good. So a row matrix would begin with 1 because you only have 1 row. All right, it says construct a column matrix to display the numerical info in the table relating for computers. So they want a row matrix for that data. So we'll do that. A column matrix. I think I said row then, didn't I? Sorry. 1, 3, 0. What is its order?
3 by 1.
Good. Excellent. A 3 by 1. And what does the sum of the elements tell you? So if I added up 1, 3, and 0, but what is that adding up?
The number of elements.
Good, the number of computers. So when it says, what does the sum, that means adding it up, of all those elements, it just says the total number of computers, isn't it? Of computers amongst the houses. Amongst houses. Okay. Now, it says convert this, the last question, convert this digit credit card number into a matrix. List the digits in pairs, one under the another, and ignore the spaces. So they're showing you this because this is actually, so matrices are used a lot in computing, and a credit card does read like this in the machine and in all the programming. But so what they want you to do, we want to display this number. So they said the numbers in lists of pairs underneath each other. So I'll write 3, 5, 4, 2, 8, 2, 7, 9, 0, 0, 2, 0, 3, 0, 6, 9. Okay. All right, so what is the order of this one?
2, 8.
Good, so 2 by 8.
Couldn't you do a 4 by 4 numbers? Or is it because it's not asking for a square?
It says one under the other, so we'll just do that. All right, so we can also represent data using these network diagrams. So when you have dots and lines, in between the dots, and the dots can be many things. It could be, it could be a map with towns or anything. But when you see these dot diagrams in maths, they're called a network. So that's what that is. So they want us to set up a matrix to display the information of these network diagrams. So what they want you to do, you have to put a 1 if the dots are joined together and a 0 if they're not. So how do you set it up? You have a look at how many points you have. So I've got a 3. And if you have 3 points, you're going to set up a 3 by 3. So what do I mean by that? If I'm saying set up a 3 by 3? Yeah, 3 rows, 3 columns. So what I'm going to do is I'm going to pretend this is town 1, town 2, town 3. I'm just going to call them towns for now. 1, 2, 3. So what you're looking for here, is there a path or a line that goes from 1 back to 1? And what that actually looks like, if you do have one, it would look like that. Is there any of that one in this diagram? No. So because there's no path there, we will put a 0, okay? Now, between 1 and 2, is there a path? Yeah. So we're going to put a 1. Okay. Oh, sorry. A 1. Okay. What about between 1 and 3? No, between 1 and 3. No, there's no, so we'll put a 0. Between 2 and 1? Yep, so 1. Between 2 and 2, so it'll be a loop? No. Between 2 and 3? Yep. Between 1 and 3? No. Between 2 and 3 and 2, sorry? Yes. And 3 and 3? No. Okay. So what do we, if we go on to this next one, what order will the matrix have to be?
4 by 4.
Excellent. A 4 by 4. Oh, I'm going to write it a bit smaller. So it's a 4 by 4. So we're going to have 1, 2, 3, 4. 1, 2, 3, 4. Is there a path between 1 and 1? No. 1 and 2? Yeah. 1 and 3? 1 and 4? Yep. 2 and 1? 2 and 2? 2 and 3? Yep. And 2 and 4? 3 and 1? 2 and 3? 3 and 3? It'll be a loop. And 3 and 4? Yeah. 4 and 1? Yes. 4 and 2? 4 and 3? And 4 and 4? No. Good. All right, and let's go do this last one. What's this one going to be, a 4 by 4 too? Yep. So we'll draw it out again. 1, 2, 3, 4. 1, 2, 3, 4. So 1 and 1 is 0. 1 and 2 is 0. 1 and 3 is 1. And 1 and 4 is 1. 2 and 1 is 0. 2 and 2 is 0. 2 and 3 is 0. And 2 and 4 is 1. 3 and 1 is 1. 2 and 3, 0. 3, 3, 0. And 3, 4, 1. 1 and 4, 1. 4 and 2, 1. 3 and 4, 1. And that, 0. All right. Well, good. So that's setting up a matrix. You might just want to also label this. When you look along lines like that, just to help you out, that's called the leading diagonal. So the leading diagonal, so if they ask you to look at the leading diagonal, they mean starting at the top left, going down to the bottom right. That's what the leading diagonal, and it's only in a square matrix, isn't it? Because you can't get a diagonal unless it's square, okay? All right, just in case they ask you that in the questions, I'm not sure if they do that this year, but they will next year. All right, let's do this. They said represent the diagram by a 3 by 3 matrix where the elements represent the number of roads between each town. So because I've got 3 towns, and they've already told me anyway, I've got to do a 3 by 3. Okay, with town 1 to town 1, is there any paths? No. Between 1 and 2, is there any paths? No. Between 1 and 3, is there a path? Yes. 1. Good. There's only one of them, isn't there? Yeah? Now let's go between 2 and 1. Is there a path? No. Between 2 and 2, they're looping. No. But now between 2 and 3, how many paths are there? 3. Good. Between 3 and 1, there's 1. Between 2 and 3, there was 3. And between 3 and 3, there is 0. Awesome. So here they've set up some data in a matrix, and they've said this diagram shows the friendship network between 5 girls, and they've called the girls 1 to 5. So there's girl 1 to 5. The network has been represented by a 5 by 5, and it's been labelled matrix F, capital F, using the rule that if you see the element 1 between the two numbers, the girls are friends. If you see a 0, the girls are not friends. So what they're asking you here is, first of all, they want you to find this element. So if we're going to find this element,
Which girl has the least friends?
well, wait a minute. So if I said F3, 4, what do I mean? I need to go to row 3, 4, which is A1. What does that mean? If I see a 1 there, what is that saying?
Girls' friends.
Yeah, so it's saying girl 3 and girl 4 equals friends, yeah? So if I say F2, 5 equals 0, that means girl 2 and girl 5 are not friends, yeah? If I sum the elements in row 3, so if I'm going to sum the elements in row 3, so that means I'll add all these up. What is that telling me? So if I add them all up, it's 3. What does that 3 mean?
Girl 3 has 3 friends.
Good, excellent. So that means girl 3 has 3 friends. Okay, which girl has the least amount of friends?
Girl 1.
Good. Girl 1, least amount of friends. And who has the most?
3.
Girl 3, yep.
Joe.
Okay.